We're going to do another geometric mean question, but we're going to do one that is a little bit harder. So I've picked out number 2 here on the one that I've given you guys in class. And we're not only going to solve for x, but we're also going to add a couple more things here. So we're going to solve for y, and we're also going to solve for z. So if you look in your textbook, you'll see some questions like this, and I want you to make sure that you can do these kind of questions. So that's why I'm going to set this up this way. So I'm going to do this and do the work on a separate sheet because there's going to be a lot of math that goes on here, and I want to reference the same picture. So for when we set this up first, I want to set up some proportions that will work. Now, when we talked about this before, we said there was a small triangle and the medium triangle, and then the large triangle is the whole big thing. It's the whole triangle. So when we go to set up a proportion, I want to make sure that I involve what I want to find. Now, the first thing that this question asked me for was x, so I'm going to try and do that. So if I use x in my proportion, and I know that I want to use that, let's move this up so you can see it a little bit. So if I want to use x in the proportion, this x is the hypotenuse of the small triangle because it's across from the right angle. So this x is the hypotenuse of the small triangle. So I'm sort of looking at this like a little diagram. So small triangle and then hypotenuse. So I'm going to want to also involve either the 25 or the 16, or in this case, this would be 9 because 25 minus 16 is 9. I want to involve either the 9, the 16, or the 25. So I'm going to need to involve the small triangle again. So I might as well use the 9. So it looks like in the small triangle that this is the smallest side. So for the small triangle, the small leg, I can use that as 9. So now I've done the small triangle with the hypotenuse and the small leg. I need another triangle that I can involve here in my proportion as well that I know is similar. So since this 25 is the hypotenuse of the large triangle, I was thinking maybe I could use that because then at least like I've got another hypotenuse involved. So I'm going to try the large triangle and see if this works. So I want to make sure you can see this. So for the large triangle, the hypotenuse is 25 and the small leg is, let's look. So for the large triangle, the smallest one is x. So that actually works. That's a proportion that I can solve. So again, how you read this, I want to make sure, I know this can be confusing. So the small triangle, the hypotenuse of the small triangle is x, and the small leg of the small triangle is 9. I'm looking at this small triangle here. Now the large triangle, which is the entire big thing, the hypotenuse is 25, and that's because it's across from the right angle. So it's this large side right here on the bottom. And the small leg for that triangle, if you look at the original picture, is x. The z is definitely bigger. So that's a proportion that we can set up and solve. When I do this, I get x squared is equal to 25 times 9. And remember when we did this before, I'm not going to go and multiply those out because when I take the square root, this is going to work out kind of nice because x equals the square root of 25 times the square root of 9. And those are 5 times 3. So x equals 5 times 3, which is 15. So that means that in my original up here, I'm going to go ahead and label that 15. So now that's the work for that one. I'm going to flip this paper around and do some more work for one of the other ones. So if I want to find y or z, I understand that for y, if you wanted to at this point, you could use the Pythagorean theorem. But I want to show you how to do the geometric mean version of this, so that way, if you can't use Pythagorean theorem, that you have another way to solve it. So I'm going to go ahead and set up some more proportions. So maybe this time I'll try and solve for y. So I want to make sure I involve y. So y is the medium side of the small triangle, but it's also the shortest side of this medium triangle. So you can set it up either way. I guess I'll start with the small triangle since I did this before. So for the small triangle, I've got y, and I'm, oops, I don't know what that was, just ignore that. So now that was in the small triangle, but it's the medium leg. So when I go to set up the proportion, I'm going to need the medium leg of another triangle, and I'm going to need something else in the small triangle. So again, I want to use the numbers that are here because those are things that help me solve. So the other thing in the small triangle that I'm going to use is this 9 because it's a number that I can use. You could use the 15 too if you wanted to. But this one is the small leg. So the small leg is 9. Now I'm going to need to use the medium leg and the small leg in another triangle. It looks like that this medium triangle makes sense because the small leg is y and the medium leg is 16. It's a number that we can use. So the setup seems like it works. So again, the medium leg of the small triangle is y, the medium leg of the, I didn't put it here, but medium triangle is 16. The small leg of the small triangle is 9. The small leg of the medium triangle is y. And so I'm just setting this up proportionally so that I don't have to draw the triangles separately. If this gets confusing to you, you can always draw the triangles out separately. So when you solve this, y squared equals 9 times 16, which means y equals the square root of 9 times 16, which when you simplify this is square root of 9 times the square root of 16, which is 3 times 4, which is 12. Which means when you go back up to your original, that means this y is 12. Okay, we're going to solve for the last one just so you can see how to solve it again using this method. So if I want to solve for z, which is way up here, again, I need to make sure I involve z in my proportion somehow. So z is, it's multiple things here. It's the medium leg of the large triangle, or it's also the largest side, the hypotenuse of the medium triangle. So I can use it twice, honestly, and I'm probably going to have to. So we said z was the hypotenuse of the medium triangle. And we also said that it was the medium leg of the large triangle. So I'm going to use that too. Make sure that when you do this, you set up triangles on one side, sides on the other one. You can't mix it or it's not going to work right. So I've got large triangle here, and the medium leg on the large triangle is z again. So that's why I set it up this way. Now the large triangle's hypotenuse is 25. And the medium triangle's medium leg is medium triangle, medium leg, that's 16. When I set this up and solve it, I get z squared equals 25 times 16, which means z is the square root of 25 times 16. You probably can already see where this is going. Square root of 25 times the square root of 16, so that's 5 times 4. 5 times 4, that's going to be 20. So when I go and label that up on my triangle, this is 20. So I've solved everything I need to on that triangle. So I understand that the setup might be a little bit confusing. You know, if you look at, I'm looking at all the ones that we did. So when we did one of these for y, again, I've got my triangles in one space and my legs on the other one. If I look at the original one I set up, I've got my hypotenuse and my small leg on one, and then my triangles on the other one. As long as you're consistent, you should be able to do it without writing the triangles separately. Remember that if you do want to do that, we did that before. And if you want to write your triangles out separately, 1, 2, 3 triangles, because that's easier for you, then you can do that. It just takes a little bit longer. So you make that choice. But for now, we have solved the triangle. Woohoo!